Good morning, everyone. How are you? How was your weekend? Okay, now grade 11th. And before we start, I would like to inform you about online exams. You have many questions, but first, let's cover our topic and then we will have revision before final exam. And I will give details. I will explain to you how we are going to solve questions. From now, if you want to get ready for your exam, you can practice from our book, which questions I gave you homework, which questions we did an online lesson. You can practice with that questions. It's really important to understand topic, otherwise you can't be prepared for exams. Now, if you're ready, let's start. Last last week, previous lesson, we couldn't finish that question. So let's final that question. I will start from question 4C, page 213, question 4C. In this question, 2 times cosine 2x over 3 plus square root of 3 equals 0. And x values, this is which we call the main values, are between 0 and 540 degree. And first of all, you will isolate cosine 2x over 3, and we will find the angles in which quadrants we are going to find. We will find it. So I told you, if you remember, take that square root of 3 to right hand side of an equation. 2 times, when you divide both sides by 2, you isolated cosine 2x over 3 equals negative square root of 3 over 2. Now, we can find our angle in which quadrants. Cosine values, in which quadrants we have negative values? In the second and third quadrants. In second and third quadrants, we have cosine values negative. If you remember, I told you that. And when you mark your lines in second and third quadrants, I told you there will be an acute angle between your line and x-axis. So that acute angles, these acute angles are equal to each other. Now, when you type in your calculator cosine inverse square root of 3, negative square root of 3 over 2, you will find your theta. What is it? When you type in calculator inverse cosine, negative square root of 3 over 2 equals 180 degree. So when you type in calculator, the answer is 180 degree. This is our angle in second quadrant. But we try to find value of x. So it equals to 2x over 3. This theta equals 2x over 3. When you do cross multiplication, 1 over 50 times 3 divided by 2, 1 over 50 times 3 divided by 2 will give us x. So what is x? 225 degree. This is our first solution. Is it between 0 and 540 degree? Yes. So to find second solution for this, when we have negative cosine, I told you in a second and third quadrants. So in second quadrant, our answer is 150 degree. And what is our acute angle between x-axis and that line is 30 degree. So it will be equal to our next acute angle. Here will be 30 degree. To find our second solution in third quadrant, this is our second solution in third quadrant. How can I find that angle? Here is 180, isn't it? So when you add 180 plus 30 degree, it equals 180 plus 30 degree equals 210. It's in third quadrant, isn't it? So this angle also gives us a negative solution. So here, but 210 is not x. It's 210 degree equals 2x over 3. So in the question, it's asking you to find x values between 0 and 540 degree. So when you do cross multiplication again, 240, it seems like 1, 240 times 3 divided by 2 will give us value of x. So from here, our value will be 315 degree. So is this answer between 0 and 540 degree? Yes. So we will just check if we have more solutions or not, because in the question it's given us the main values, x values between 0 and 540. If we have more, we will find it. How we can find it? What is our period of a function? We can add it to find. When you look at here is our formula to find more x values. Theta is here. First one, you can write 150 and plus 2 pi times n. N, what is n? In this formula to write n, I will use like 0, 1, n of it. So when you add this one, 2 pi, we know 2 pi, what is it? It's 360. 360 degree, 2 pi. According to our period of a function, we will add. When you add, it will be, but here, what is our period of a function? So how we find the period of a function? We find the period of a function, coefficient of x is 2 over 3. So what do? We will divide 360 divided by 2 over 3. We will find our period of a function to add it. Like here will be period of a function, not always 2 pi, according to period of a function. Period of your function. So here we won't have any more. You can see also here when you add 225, for example, even if you add 360, it will be greater than 540. That's why we only have two solutions, 225 and 315. I do not want you to confuse with this detail. Do not focus on here. For your exam, what is important for you to know that how to solve that cosine or sine function to find values of x. You first you find in which quadrants you have your solutions and you calculate. This is important. That's why this detail for now is not important. I don't want you to confuse more. So let's continue with one more question. How do we solve that question? From page 213, question 7e. Let's do it first. In this question, 5 sine x times cosine x equals cosine x. 5 sine x times cosine x equals cosine x. What do we do? First of all, let's take that cosine x to left-hand side of an equation. So when we take it 5 sine x times cosine x minus cosine x equals 0. Okay, what we do next? What do we have? We will apply factoring. We will apply factoring to solve equation. When you apply factoring, how we factor it? We have sine x times cosine x. We have multiplication here, and we have cosine x. What do they have common factor? It's cosine x, isn't it? So I can write in brackets cosine x, in brackets 5 sine x. It comes from the first one, and second one, what do we have? Negative 1. So when you expand brackets, you will find your question. Cosine x times 5 sine x is 5 sine x times cosine x, and cosine x times minus 1 minus cosine x equals 0. We factor it. So when you apply factoring, it's important, factoring. First, we apply factoring. Now, what do we do next? I will equal h to 0. When you equal to 0, cosine x equals 0. 5 sine x minus 1 equals 0. Okay, first do cosine x equals 0. How we can find it? Cosine x equals 0. When you use your calculator, inverse cosine of 0, inverse cosine of 0 equals x. Okay, in which values we have cosine x 0 when you use calculator? Even when you check your quadrant, do you remember from unit circle? So cosine values are x values. Cosine 0 is 1. Like, how do we find inverse cosine 0? 90 degrees, isn't it? Cosine 0 is 90 degree. So cosine 0, like cosine, inverse cosine 0 equals 90 degree. And where we have one more cosine value at 0, between 0 and 360, it's at 270. 270 also will give us cosine 0. Cosine 270, inverse cosine 270, inverse cosine 0, sorry, cosine 270, when you use calculator, you will find 0. These are our two solutions. Like, if you remember, x-axis gives us cosine values, y-axis gives us sine values. Do not forget it. We learned when we were doing unit circle. Now, two more solutions we have. What do? We will isolate sine x again. How? 5 sine x equals 1. When you take 1 to right hand side of an equation, it will become positive 1. When you divide both sides by 5, sine x equals 1 over 5. It equals 0.2, isn't it? Sine x equals 1 over 5, and it's positive 0.2. In decimal form, you can write it. So sine x, in which quadrants sine values are positive? In the first quadrant and second quadrant. When you make your line in the first quadrant and second quadrant, we have two solutions in the first quadrant and second quadrant. If you remember, all students trust Cambridge. So according to that rule, we have sign values in first and second quadrant positive. So when we find acute angle here, we will use that acute angle to find our second solution. So how do we find our acute angle in first quadrant? Inverse sine x. Inverse of sine 0.2. Inverse of 0.2 will give us first solution, which is an acute angle in a first quadrant inverse sine. So when you type in a calculator, inverse sine 0.2 will give us 11.5. It's a decimal point. X equals 11.5. I will write with one decimal place, 11.5. This is our first solution. Here it is, 11.5. To find second solution in a second quadrant, I told you you can use that acute angle they make with x-axis. It will be same. It 11.5 degrees here. So when you do 180 minus 11.5. So why? Because it's in the second quadrant, and we know the acute angle. We know that acute angle between x and that line. So here is 180. We know it. So 180 minus 11.5. 168.5. This is our second solution. 168.5 degree. So for this question, you have four solutions, four different solutions you have. First, what we have done, we applied factoring, and when we factor it, what we have, cosine x equals 0, 5 sine x minus 1 equals 0. So inverse cosine 0, 90 and 270 degrees we have, and they are between 0 and 360 degrees. And here for the second, when you isolate sine x function, sine x equals 0.2. From inverse sine of 0.2, acute angle is 11.5. It's in the first quadrant. To find second quadrant, second solution in the second quadrant, we subtract from 180 degree. Okay. Now let's start our new topic, trigonometric identities. For trigonometric identities, here what you see, sine square x from page 214, sine square x plus cosine square x equals 1. This is called trigonometric identity. Why? Because it's true for all values of x. It's true for all values of x. Now, to understand that, let's start with an example. Exercise 9.7, page 215, question 1. Prove each of these identities. Now, in the question, it's given 1 minus sine square x divided by cosine x equals cosine x. We will prove that they equal to cosine, they equal to each other. To prove it, what I will do, first of all, I will get that first part, I will simplify it, and I will prove that equals to cosine x. Okay, let's do it. 1 minus sine square x over cosine x. How can we simplify? What do we know? We know one identity which is always true. What is it? Sine square x plus cosine square x equals 1. Okay, when I isolate it, when I leave cosine square x alone, cosine square x, when I isolate cosine square x, so 1 That means I take that sine square x to the other side of an equation, 1 minus sine square x. Okay, and the question, can I write instead of 1 minus sine square x, cosine square x? Yes, because they're equal. So divide by cosine x. Cosine square x divided by cosine x, when you simplify, it's cosine x. Because we know that cosine square x means cosine x times cosine x. Cosine x times cosine x. So simplify by cosine x, only you will have cosine x. So we prove that they are equal. So we prove that they are equal. When you simplify cosine x, simplify by cosine x, what do you have now? Only cosine x. That's all. So when you have trigonometric identities to prove that questions, that type of questions, you will use that identities which are always true. And here it is, the answer. Let's do next question. To prove from question 2, I will do E. Prove each of these identities. First of all, to prove this question, I can take that first left-hand side of an equation. I can simplify it, and then I can simplify second part to prove that they are equal. Let's take it first. Left-hand side of an equation, 2 minus sine x plus cosine x squared. To do it, how do we do it? When you do it, 2 minus, when we get square of that equation, how do we do quadratic equations? First term square is sine square x and plus 2 times first term times and second term cosine x plus cosine square x, cosine square x, second term square. It's here, isn't it? So this is our first part. I did what? I expand brackets to get square of terms. So sine, what do we have now? 2 minus sine square x plus 2 sine x times cosine x plus cosine square x. What do we do now? What will we do now? To do this question, sine, I know that identity which is always true. I can say it here. I can simplify in brackets what I have. Sine square x plus cosine square x. What is it? It's 1. So in brackets what I have, 2 minus 1 plus 2 times sine x times cosine x. Now what will I do? I will expand brackets. So when I expand brackets, what we have? Let's see it. When you expand brackets, you will multiply by negative sign. So you will receive that subtraction in brackets. 2 minus 1 minus 2 times sine x times cosine x. One more step, we can simplify what? 2 minus 1 is 1. It equals 1 minus 2 times sine x times cosine x. Now we will prove that it equals to what? Sine x minus cosine x squared. To prove it, let's do this. How we can, you can do, I know mostly you do that sine x minus cosine x times sine x minus cosine x. if you want to do that in that way, you can do it. If it is easier for you to expand brackets, sine x minus cosine x, you can do that. So when you multiply each term by in the bracket what you have, you can find it. But I will do it in a short way. First term square, what is it? Sine square x minus, since here is subtraction, 2 times sine x times cosine x. First and second term, and plus square of second term. What is it? Cosine square x. Okay, now can we continue to simplify it? Yes, we can. What do we do now? We know sine square x plus cosine square x equals 1. Okay, to let you see it clearly, I will rearrange a quadratic equation. Sine square x plus cosine square x minus 2 sine x times cosine x. Now, can you see that identity which is always correct? Sine square x plus cosine square x equals 1 minus 2 times sine x times cosine x. Yes, are they equal? We find that answers, they are equal. 1 minus 2 times sine x times cosine x. Okay, now if you have any question, you can ask. We can let you to ask you question, and I can answer your questions. Click raise hand, and we can answer your question. When we are waiting for questions, let me show here. Sine square x plus cosine square x equals 1. I wrote it here. 1 minus 2 times sine x times cosine x. Yes, good morning.
Teacher.
Yes.
Good morning. Can you
Good morning, Oliana.
It's
yes.
Shayla.
Shayla, is it you? I have confused, sorry. Yes.
Okay, teacher, can you explain the first exercise that you did today?
From previous lesson question.
Yes.
This one?
Yeah.
Okay, now Shayla, let's do it together. In this question, if you remember previous lesson, I isolate cosine 2x over 3. I tried to leave it alone. Is there any question how we simplify, how we isolate cosine 2x over 3?
No.
Okay, so Shayla, is this value, it's a negative answer, isn't it?
Yes.
Negative square root of 3 over 2. This answer, in which quadrants do we have cosine values negative?
Second and third.
Yes, second and third. So I will make lines, I will mark lines in second and third quadrants here. So between that lines and x-axis, we will have equal acute angles. So Shayla, when you type in calculator cosine inverse negative square root of 3 over 2, what is your answer?
150.
Yes, but this is not x. What is it? It's equals to 2 times x over 3, isn't it?
Yes.
So what do we do to find x? Cross multiplication. What is the answer? 225 degrees, isn't it?
Yes.
Any question here?
No.
To find second solution, it's in third quadrant, isn't it, Shayla? How can we find?
Yes.
Till here, it's 180 degree, isn't it?
Yes.
So when I add that acute angle, second solution will be 210, isn't it?
Teacher, but how we find this acute angle?
That acute angle, here is 150, here is 150, isn't it?
Yes.
From 0 till here, when you hit a red line, it's 150. To find this acute angle, how can I find it? Do you remember?
Yes, 180 minus 150.
So it equals to 30. So I told you that acute angles will be equal. Between x-axis and our line, there will be an acute angle, so that acute angles will be equal to each other, so 30 degree. Here will be 30 degree too, okay?
Yes.
So when you use that acute angle, you will find your second solution, 210. But this is also not x, it equals to 2x over 3. When you do cross multiplication, 210 times 3 divided by 2, x will be 315, isn't it?
But teacher, why 210 is equal to 2x over 3?
Because 210, when you type in calculator cosine 210 equals negative square root of 3 over 2. Like what we have done with 150. This is not x. This is 2x over 3, okay? In the question, it's not theta angle is not given x. It's given 2 times x over 3. So this is 210. So I want to find only x. So to find x, we do cross multiplication. So 210 times 3 divided by 2 will give us x is 315 degree. How is it now? Did you understand?
Yes, and then you show us another formula that is
Yeah, that
x
formula,
is equal to
yes.
delta.
Yes, that formula to find more values between that range which is given in the question. This is just a, for you, it's a detail. Normally, it's useful to find angles for that range. But for now, I do not want you to confuse. I will not ask that kind of questions for your final exam. That's why I stopped there. Just know here there is a formula to find more values in that range here. Like if to find till 540 degree, here is our formula. That theta is in the question we found here 225 to add 2 pi n, and you can substitute 0, 1, 2, okay, to find x value. Next lesson we can do one question about this one, okay, to use that formula. Next lesson we can do with
Teacher,
yes.
About the exam, what are the topics that we need to study?
Final exam, it's same. What do we do for final exam? First term topics. What we have learned, circular measure and trigonometry. But I will give you more details, how many questions, what type of questions you will have in the exam. I will give details to you next coming lessons, okay? We will have revision online lessons, 2 or more than 2, maybe, let's see. But we will have 2 online lessons for revision, okay? We are about to cover our topics for this term.
Okay, thank you.
After trigonometric identities, we will not have a new topic. We have one more further trigonometric identities and we will finish our topic. So for today, we can finish our lesson. Have a nice day. See you next lesson.